Hello guys, welcome back. This is part 2. We have 2 more people who have generously did theirs. So let's look at Noah's, because I'm sorry Steven, I'm not going to do yours first. You did get a little more wrong, so I do want to do this one. And I advise you to watch this one, and the next one will focus on you and what we have left. But because you answered more wrong, I want to do this one first, so we don't have longer videos. If you understand me. So you got the first 3 right. The 4th one is what molecule donates electrons. I think we went over that. We did go over that in the first video. Noah, make sure to watch that. The next one you did is osmosis, an example of. We did not go over this. So our first one is number 7. We can find number 7 in here. Osmosis happens naturally. Osmosis is the diffusion of water. It's just the diffusion of water, and it works as regular passive diffusion works. It goes from a high concentration to low concentration. So we always want the isotonic solution. That's the goal. That's why water moves. But osmosis is an example of passive diffusion. So let me actually go there. This is question what? You got question 7 wrong. So if we look here, question 7 it'll be passive transport. Passive, because it does not require any work. No. It doesn't need any energy. That's what I'm saying. So even for you, Steven and Noah, and anybody out there, it's not just these two. Just these two generously came and did this. It is passive transport because, again, it does not require any energy. The water just moves on its own, which is the definition of passive transport. So just remember, this is passive transport. The next one that Noah got wrong is diffusion. We've talked about this in our last video. Please check it out. I don't want to explain myself. I do want to keep these videos short. It helps keep me from waiting too long and things like that. So this one, 15. Okay, 15 is something we haven't talked about, and I want to go. So question 15 is right here. And both of you guys got it wrong, so good thing I'm going over. It's the stroma. What is the stroma, you ask? The stroma is the cytoplasm. Do you know the cytoplasm of a chloroplast? This is where Calvin cycle occurs. Let's look at this right here. The stroma is thick fluid filled the inner compartment of the chloroplast. This is like the chlorophyll of chloroplast. No, not chlorophyll. I mean cytoplasm of the chloroplast. So if we look here, the question is asking, where does the Calvin cycle occur? So the Calvin cycle, it doesn't say here, but if you where does it say? It's I'm very sure it's in the stroma. If you just search it online, it will give you. I'm just not sure why it's not giving. It's not on the slides, I guess. It's one of those things. Yes. So if you search it online, it will give you stroma. This is what my basis is on. I do believe that it is stroma, even though it's not in the slide, which is kind of a trick, but it's the stroma because, and stroma is the cytoplasm of a chloroplast. So you went good until you reached 24. This type of bulk So we haven't talked about transporting things. So is it here? Yes, bulk transport. So we have phagocytosis, which is pathogens. Phytocytosis, which is small molecules and liquids. Phago, maybe big things. Phago. And then phagocytosis is very small things, small molecules. And then we have this. And mostly phytocytosis are small molecules. Phago. Phago sounds a little bigger. Think phago, bigger, phago, or whatever how you say it. It sounds bigger to me than pheno. Pheno has a lighter, even though they both start with a P. Phago just rings out a more excited, more loud, while pheno is less and quieter, smaller. Next one you got wrong is the cellulose is composed. Cellulose is a sugar. Anything that ends in lose is a sugar. And we need to go to chapter 3 for this. And every sugar is a... So let me just show you this in action. Our first one is carbohydrates. Carbohydrates are sugars. Here's examples of sugars. Lactose, glucose, fructose. They all end. Cellulose. So all of these, it's a sugar. Sugars are carbohydrates. Next one, the mass of the mass number of a electron. Electron is mass number of an element is protons and neutrons. Mass number is the protons and neutrons because those are the ones making up mass. Electrons do not make up barely any mass, so we kick them out of the equation. So we only have protons and neutrons, which are similarly massed. So we only have those two in our equation. We just add them to find the mass, the element mass number. Pretty easy. I'm not going there. Okay, you're trying to join together amino acids. Here we go. We were just here, right here. Dehydration and hydrolysis. These are the two options. You either can break or add. When you add, you want to remove water, dehydration. When you want to add, remove water. When you want to break, add water. That's what the names really mean. And when we're binding amino acids, we're removing water to add to amino acids. So the next one you got wrong was this. What method of movement? I will go to the this right here and talk about cilia are tiny hairs all around the membrane. Here is commonly known as false foot. And in the question, it had false foot in it. Which one? Yes, which method of movement? So 37. We want to look at 37. I know these questions by heart, but 37. 37 is sphetopod because it means false foot. False foot, cetophoid. So that is false foot. Not in all cells, but they will extend false foot to get around. Most common in amoebas. But that's the answer for that. Cilia are tiny hairs all over that help them move. Cetopod, false foot. Those two words go together. So the next one that you got wrong is... This is a bug. Okay, we done that. We're on 37, I believe. Yes. So 38. What are the crucial products? Okay, so this question is asking what is important. I'm not sure. I'm going to go over it. Even if we went over it already, I'm going to go over it again. What are the crucial products in the photosystem, which is the light-dependent reactions that are important in the light independent reaction, or the Calvin cycle. So what's made in the light dependent reaction are ATP and NADH. NADH transport electrons that are going to be used as energy, and ATP is energy. So those two things will be moved to the NADPH, to the Calvin cycle. These two things will be moved to the Calvin cycle, and we'll use these things. Let me show you. Please watch my video on photosynthesis if you're still confused of what I'm talking about. Well, look at this. These two are made. Look, ATP is made and NADPH. And if we look at the Calvin cycle, we see ATP and NADPH being used. So the next one on our list is size. Okay, size and 50. Okay, we've discussed this, so please watch the first one. So really number 50, and we have to go to enzymes for that. You really need a little bit of help for this chapter. Chapters 5 and 6. 5 and 6 you might need a little bit more help on. They're a little bit confusing, but I think you can do this. Thank you for taking the test, though, by the way. It really helps. Okay. So we're talking about enzymes and denaturing. Proteins denaturing. So here's the slide. We have factors. pH, you were right. Temperature, it says until peak rates of reaction rises when until peak temperature results in enzyme duration. So the question was pretty sneaky. If we go to the last one, the very last one, you both got this wrong, so please go. It says prior to reaching peak temperature. So what else is a sim? So salt, too little salt. You both chose the salt option. Salt can alter. Too much salt too, and pressure as well. So that's it for Noah. Good job. Thank you for doing it. It really helped me, and it'll really help everybody else. We got another, let's say, 6, 7, 8 questions that we really wouldn't have gotten to if you didn't take it. It would probably help a lot of other people. So thank you very much.